In order to know what to do about homelessness in the United States, we need to know how many homeless people there are. One way to find out might be to pick a night and send out armies of people to try to count each and every homeless person. The name for this is a census, a count of every person or item in a group. That seems like the most thorough way to get at accurate information. But as we'll see, taking a census is not always as easy as it appears. For example, when a truck full of potatoes arrives at Frito-Lay, the company has to figure out what proportion of them are bad in order to decide whether or not to accept the shipment. They could do a census, cut up every potato to look for defects, but that would be a real headache. Instead, it's more practical to use a sample, a part chosen to represent the whole. Samples give accurate information or meaningless numbers depending on how they're chosen. In statistics, a good sample is chosen by chance. In this unit, we'll be looking at the most basic type, the simple random sample. One of the more radical ideas put forward in the U.S. Constitution is that of a nationwide census. Each citizen is counted every 10 years, and representatives to Congress are apportioned according to the population of each district. This counting is fundamental to the one-person, one-vote concept of democracy. The first census, conducted by Thomas Jefferson in 1790, counted almost 4 million people. But counting everyone proved to be an impossible undertaking, and many people were missed. The census has been taken every 10 years since then, and overall accuracy has been improving, but the process is still not perfect. Barbara Baylor is committed to making sure the census counts everyone. She is former head of statistical research at the Census Bureau and is now executive director of the American Statistical Association.
The undercount problem, though, was recognized very early in the census. In fact, George Washington recognized that there was an undercount problem in the very first census. It was not ever really seen as a real difficult problem as long as it was thought that everyone was undercounted at the same rate. It was found then, when we got more sophisticated statistical techniques, that the undercount was not uniform, that it was primarily in the minority communities.
The undercount in the last census ran about 6% for minorities, that is blacks, Hispanics, and Asians, and less than 1% for whites. So you can see there's a significant shift. We're talking about hundreds of thousands of people. And so it's based on that we have to truly understand that the undercount cuts in to participation in the political process of minorities, because if the count is not right and we lose them, then we're losing representation.
In 1990, 249 million Americans were counted. But if everyone isn't included in this figure, then minority communities lose their fair share of the billions of dollars in federal funds granted on the basis of census data. Funds that are used for hospitals, for schools, for social services, for daycare centers, and other community infrastructures. The first step in conducting the census is mailing a questionnaire to every household in the United States. In 1990, only 3/4 of the questionnaires were returned to the Bureau within the allotted time. A census taker must visit those households that do not respond by mail.
How do you do? My name's Carol Buchanan. Our records indicate that you haven't responded to the 1990.
In 1990, a separate attempt was made to try to account for the homeless.
We would like to take a few minutes to ask you a few questions. It'll only take a couple of minutes.
Overall, 450,000 census takers were hired to follow up on those who did not fill out census forms. It's here that minorities are often missed.
There are lots of reasons why it's difficult to count minorities. One is the census procedures themselves are devised by people more or less like myself, middle-class people who think about other people living in similar circumstances. It's very hard to think about the homeless and how they might be counted, and we know we don't do well with the homeless. There are people who do not want to be counted. People who are in the country illegally cannot see that even though they're promised confidentiality, that the Census Bureau won't turn around and give that information to the Immigration Service.
And then the last set of reasons is just apathy. They have been promised many things by the government in the past. Some of them have not happened. They're turned off a bit to society, and they're really not moved by another government agency coming out there and saying, we're here to do something good for you. Those are difficult things to overcome. These are not procedural errors in the sense that the address is not on the census list or anything like that, or the questionnaire did not arrive at the house. They're people choosing to leave themselves out.
Stand right up for who you are. Stand up right now. Stand up and be counted.
Barbara Baylor and other experts have proposed statistical adjustments to correct the undercount. In fact, there's a controversy in the courts over whether the census figures should be adjusted based on a smaller, intense sample of the population. In statistics, a sample is a part we choose to represent the whole. The population, whether it's people or potatoes or grapes, is the entire group we want information about. The sample is the part we actually gather data from. Because the sample is only a part of the population, we can study it more extensively than we can all of the members in the group. We then use the sample data to draw conclusions about the entire population. A truck pulls up to a Frito-Lay plant in Killingly, Connecticut, filled with potatoes for chips. And from the point of view of the people at Frito-Lay, these potatoes are the population. The sampling process begins as soon as the truck pulls up to the receiving dock. Every truckload carries about 45,000 pounds of potatoes. The inspectors can't look at every one. And even if they could, it would produce too many mistakes due to human error. Instead, they take a sample, filling 30-pound buckets at 5 different points down the length of the truck. Frito-Lay can get better information by studying the 150-pound sample. The first step. The inspector randomly selects 40 pounds of potatoes and punches a core through each one. The hole down the middle makes it easy to spot the samples when they undergo a cooking test. Now, 10 more pounds are set aside, leaving an even 100 pounds on the table. The inspector searches for internal defects, green edges, mechanical damage, and other flaws. Each defective potato is weighed, and if the sample percentage is too large, the whole load must be rejected. Meanwhile, Rita has peeled the cooking sample, so she can toss them directly into the slicing machine. Then she plucks out the sample chips and hands them over for testing at a mini laboratory right on the plant floor. Less than 45 minutes later, Rita will get the results from the cooking sample and the inspection data. Everything meets specs, so based on a sample, Frito-Lay will accept the shipment.
Oh, there you are, Willie Mike. Excuse me, guys. Nice lot of potatoes. You can go ahead, weigh up, put your truck on for number 2. Okay?
This lot of potatoes is on its way. Precise sampling procedures, using just 150 pounds of potatoes, enable the receiving department to approve the entire 45,000-pound shipment. After washing, potatoes tumble into the peeler, and then into the slicer, out of the slicer and into the fryer. Hot oil and a little salt, and in no time, ruffles. Turning raw potatoes into finished chips is a straightforward process, but making sure it's functioning properly requires the coordinated efforts of a number of people. All along the production line, workers are taking samples to ensure that the process is on track. If they waited until the end of the line to inspect the finished product, problems that were minor to begin with could be greatly compounded. Instead, sampling at key points catches problems early, before they get out of hand. The cooked chips travel out of the production area and into packaging. A few ounces fall into each of these automated bins. When the bins add up to the proper package weight, the chips are released. Packages are stamped with the plant number and other coded data. Then the bags are ready to be filled with chips. Rigorous sampling procedure is as important in packaging as in production. Here, an inspector measures a sample of 4 bags to make sure the net weight is satisfactory. Even when they're put into shipping cartons, the ruffles are still subject to sampling. No underweight packages can leave the plant, so cartons are randomly selected off the packaging lines for a final check before they are loaded into trucks and driven to Frito-Lay distribution centers. And even after the local route trucks have delivered the chips, Frito-Lay continues to rely on sampling. Professional shoppers across the country go out each week to purchase 2 bags of every product with different code dates. Shopper samples are sent to company headquarters in Dallas for testing and comparison. On all Frito-Lay potato chip products, you'll find a list of ingredients. The only one missing is the most essential: proper sampling. Now, how do we select a sample from a large population, like all Americans? The easiest ways are not always the best. Every couple of years, Ann Landers conducts a mail-in survey on interesting topics through her syndicated column. In 1989, the response was huge: 141,210 people. 82% of these respondents said sex after marriage was less exciting than it was before. Can we take it from this that most Americans are bored with their sex lives? No. Ann Landers' sampling method is called voluntary response. These samples are usually heavily weighted with people who feel strongly about an issue, especially people with angry or negative feelings. For example, in an earlier survey about families, Ann Landers asked parents whether they'd have kids again. 70% responded no. An independent randomly selected survey yielded a 90% yes response. So as fun as these juicy tidbits are to read, Landers' survey is not representative and therefore biased. Her numbers don't tell us much about the population of all Americans. The way to remedy the problems posed by voluntary response is to let impersonal chance choose the sample, so that there's no bias favoring one group or another. We'll use a small sample to illustrate how this is done. Let's say the population we're interested in has 14 people in it, and we want to choose a sample of size 3. First, each subject gets a numerical label. Every label has to be the same length. In this case, we use the 2-digit labels 01, 02, 03, and so on. Then, we use a table of random digits, made up of a list of digits that have been chosen completely by chance, giving every number 0 to 9 the same chance to appear in every position in the table. So each pair of digits is also equally likely, and the table will choose labels completely at random. We just proceed through the table until we match pairs of digits with labels in our sample. The first pair of digits in the table is 12. The name that has the number 12 is Muir, so Muir is in the sample. The next pair of digits is 09. That's Watt, also in the sample. We jump over the gap for the next 2, 57. That's not one of the labels. We had only 14 subjects, so we skip it. 69 and 41 aren't labels either. 14 is, so Riley is the third person in our sample. This way of choosing is called a simple random sample. Chance gives every individual the same likelihood of being chosen, so we've eliminated the possibility of favoritism. In fact, chance does more in a simple random sample. Every possible grouping of 3 in our population had the same chance to be the sample as the one we chose. Choosing a sample correctly makes all the difference in the quality of our data and interpretations. In statistics, choosing well means letting chance do the picking. It's the only way to avoid the pitfalls of human choice. Sometimes, though, we need to count every single member of a population. In these cases, a census is a thorough and sometimes difficult method for finding out something we want to know.